This is video number 2 where we're going to do some examples together, and you can pause at any time to write on your paper. So let's read the directions. For each of the formulas below, build the covalent molecule with the model kits and complete the following. Draw the Lewis dot structure, show the bonds and unshared valence electrons, build the molecule, make a 3D sketch, attempt to show the shape the atoms actually take, and name the shape of the molecule. Use your reference sheet or the Schoology flashcards. So this first one, the formula is H2. As a reminder, the little 2 always tells you how many of what comes before. So this would be 2 H's. Here's 2 H's and 1 O, because no subscript means 1. Here's 1 N and 3 H's. The little number tells you how many of the thing before. So capital N is 1 and capital H 3. 1 C and 4 H's. Okay, so if I know I have 2 H's, I'm going to draw the Lewis structure. The first thing I'm going to do is looking at this. How many valence electrons does it have, I should say, and how many bonds does it need? So hydrogen, I hope you're starting to remember, it's our unique one. And hydrogen has only 1 valence electron because it's in the first group. And it only needs 1 bond because it's so small. It just needs to have 2 to fill that first energy level. So that's my first step. And I like to write that here, valence electrons on top and bonds below, just as kind of a little scratch paper area. Now I'm going to look at step 2, put the atom that needs more bonds in the center. That's not really a factor here because there's only 2 atoms, so there's not really a center. Then use single bonds to connect first. And group 1 and 17 only get 1 bond, so that's a good reminder. So I'm going to write H, single bond H, and that reminder tells me I shouldn't need any more bonds. So number 4, add double and triple bonds where needed. We don't need any more. And another place we can check is the bond chart. See how on H only has 1 bond showing? And so I should always only see 1 bond touching an H in all of my Lewis structures. So last step is how many valence electrons do they have, and add unshared pairs as needed. Does hydrogen have any unshared pairs? There's 2 ways to tell. I look here, no it doesn't. Also, when the valence electrons and the bonds are the same, that tells you that the valence electron for this hydrogen is in the bond, and so there are no extra unshared ones. Remember, every time an atom makes a bond, it has to share 1 valence electron, and the other hydrogen has to share 1 valence electron, and that's all they have. So there are no unshared. They're both being shared, 1 from this atom, 1 from that. So that's it for hydrogen for the Lewis structure for H2. Now the next step, don't forget this, you need to build the molecule. Sometimes you can tell by looking here what the shape will be, but sometimes it's harder to tell. So because it says H2, you can look at the cover of your box, but I'm going to need 2 white ones and then a single bond. I'm going to use a short plastic. And then I just connect them. And some of these maybe don't fit as well as others, but make it work. And you can see the shape then more clearly. And then here we're going to do a 3D sketch. Since this is just 2, it's not as hard to sketch. You can try to, if some of you are artsy, you can shade it a little if you want. And then last, the shape name. The shape name, if you don't know it, you can look at this Vesper reference sheet, and I see how 2 connected are always considered linear. They are in a straight line, and you can see the word line is the word here, but it's pronounced linear. All right, we move on to the next one. If you want to try it on your own, you can pause, but I will do the next one for you. H2O. So first step is to do the Lewis structure. Looking at my steps for doing that. How many valence electrons does each have, and how many bonds does each need? So H, when we look at our bond chart, we remember it has one valence electron because it's the exception. It doesn't have 7, it only has 1, and it needs 1 bond. So valence electrons on the top, bonds written below just as some scratch paper. Now oxygen is group 16, so it has 6 valence electrons, and that means it needs 2 bonds, because remember the octet rule, these are going to add up to 8. So 6 valence electrons and 2 bonds. That helps me for the next step. Put the atom that needs more bonds in the center and use single bonds to connect first. So if I look here, I see hydrogen only needs 1 bond, but oxygen needs 2. And I have 2 hydrogens and 1 oxygen. So I'm going to put the oxygen in the center and connect with a single bond first. Next step, add double or triple bonds where needed to make the right number of bonds. See the bond chart. So when I look at oxygen, I see that it needs 2 bonds. How many bonds needed? That's the red number. And I see that can happen either 2 single bonds or a double. And I look at my picture and I have 2 single bonds touching that oxygen. So I don't need any more bonds. I don't need a double because that would make 3. And hydrogen doesn't want more bonds either. So that means I'm now on step 5. I'm not going to add double or triple bonds. Step 5, how many valence electrons do they have? Add unshared pairs as needed. So with hydrogen, we talked about it before, its only electron is in the bond being shared, so no dots around hydrogen. And again, I do see that on here, there's no dots around hydrogen. But oxygen, I can see here that it has 4 dots. Let's see why. The reason is oxygen has 6 valence electrons, but only 2 bonds. So 1 of the 6 is in the bond here, 1 is in the bond here. Those are shared, so it has to share 2 of its electrons to make the bonds, but it has 4 more that are unshared. So 4 dots, you can put 1 of them above, below, or you can put 2, 2. It doesn't really matter, but you can see how the way I drew it here looks just like the bond chart, and that makes it easy to tell that it's done. And now the oxygen has 8 around it by sharing, even though it really still only has 6 of its own electrons. All right, next step is to build the molecule, and here's why. If I look at these 3 in a row, they kind of look like this linear one here. But when we build it, let's make sure. So I'm going to take a red one for the oxygen and 2 white ones. Take this apart from before. 2 white ones for the hydrogen. And then I'm going to take 2 small single bond ones for these bonds. And now I connect, and because of the way they made the kit, it helps me to see that it's actually not a straight line, is it? And why? It's because of the unshared pairs pushing the bonds to make room for themselves. There's actually 4 areas of electrons around this central atom. So there's 2 atoms around the central atom, but there's 4 areas of electrons. So now I'm going to sketch this. If you want to make it a little bit 3D, you can. And then if you want to add the unshared electrons, you can. I put them both up here because I'm imagining them above, pushing these down. And so now I see from my chart that 3 in a row, or 2 around the center. So this has 2 around, but no unshared pairs. Here has 2 around and 3 groups of electrons, that's called bent. And 2 around with 4 groups of electrons, that's also called bent. So this is 4 groups of electrons, and so it's a bent. Okay, it's like a straight line that got bent by those unshared electrons, repelling and pushing those down. Now, if you want to pause and keep trying on your own, you can, but I do want to show you with the oxygen, because that's where we might need a double bond. So let's look at oxygen next. First thing I'm going to do is draw the Lewis structure. How many valence electrons does it have, and how many bonds does it need? We just did oxygen up here, so it's going to be the same. We're 6 valence electrons and 2 bonds. The little 2 means I have 2 oxygens. Since it's just 2, there's not really a center. Put the atom that needs more bonds in the center. That doesn't really apply here. Use single bonds to connect first. So O, single bond O. Now, don't start putting on dots. You've got to do the bonds first. Number 4, add double or triple bonds where needed to make the right number of bonds. See the bond chart. Remember that O needs 2 bonds. It could be 2 singles if it's between 2 things, like it was with this one, but it can also be a double attaching to one other thing. So since I'm not between, I have to do a double. So put the bonds first before the dots. Otherwise, you'll probably end up putting too many dots on here. So now I think I have the bonds right. And now I'm going to look at the last step. How many valence electrons do they have? And add unshared pairs as needed. So since oxygen has 6 valence electrons and 2 are in the bond, that means there's 4 here, and also the same thing on here. So we talked about that up here. It's the same thing. 1 in the bond, 1 in the bond, that's 2, 3, 4, 5, 6. So 2 are being shared in the double bond from one oxygen, 2 from the other to make our double bond, and that means 4 are left from each. So when we're going to build this, the next step is to build the molecule. This time I'm going to take 2 red ones, because red is oxygen, and I'm going to take the long connectors because it's a double bond, and you'll see why. So if I use the short ones, it won't reach. I'm taking this and then I reach across like this, so there is the way the model shows a double bond. So I'm going to draw that. All right, and then you might already know the name of this shape, but let's take a look. Just because it has a double bond doesn't mean it's not the same shape as this. It's linear. All right, you can keep going. I am going to make one more video that you can use for the back side if you need more help, but that's the end of this one. Thank you.